This video is for COP 4020 at the University of Central Florida. Its purpose is to provide a lecture that will not be provided in class because of the coronavirus and the fact that UCF is not having students on campus for the next couple of weeks. So we're going to talk about more graphics, more graphing, more statistics, and so forth. And we're going to start off with the cycler data that we had used in class the other day. So here we go. Notice in this recording you can see I've already set cycler data in. And one thing I want to point out that this mostly has to do with using creatine to help cyclists and their endurance and their performance. So let's take a look at it. Okay, and you'll see age, gender, the treatment, TRT stands for treatment, none, medium, low, and these are the levels of creatine that are administered. So anyway, it doesn't really matter what the data is, but you just want to always want to take a look at it before you actually start using the data to do anything. So let's go ahead and do a simple plot. We'll do a box plot. So let's go ahead and make a picture of this. We'll use a box plot. Cycler $1, CPK1. So we're just going to go on that first data. Let me move this into. Okay, so that's what we get, which isn't very exciting. Now you'll notice that there are 4 different CPK columns, CPK 1 through 4. And one of the things we'll be dealing with is how to sort of put them on the same graph and do a comparison. Let's fancy that up just a little bit. That's nice, but as we talked about in the last lecture, we can make it look nicer. CPK for the y-axis, x-axis equals time 1 equals CPK at time 1. And lastly, let's do a little color. See, green. Okay, so that'll look a little bit nicer. Want to make sure I haven't missed anything. Okay, and I know I'm going to have to drag this in because every time it appears, it's slightly outside of my recording area. So now we have it dressed up just a little bit. Which, when you do your test, you want to make sure you have all your axes labeled and a title and so forth. By the way, let me do one more thing, just so that I can talk about one of the requirements that'll be on the test. Remember, we said that you're going to need to move this over just a little bit, see if I can have them both showing. Okay, remember we talked about the fact that you're going to need to be able to just describe. So let's say the shape of this is skewed right, center about 490 to 500. Okay. Let's make that a comment and not an @ symbol. Okay. Spread 200 to 720. And the fourth thing is we're going to say unusual features, no outliers. Okay, so that's going to be required on your test. That you're going to have to describe graphs that you make. Okay. So let's go ahead and make this horizontal. You could say horizontal equals true. And sometimes being horizontal is going to be a little bit easier to read and deal with. You're just going to have to make a decision on that. Okay, now what we're going to do is we're going to add some extra data in here. So we're going to say box plot cycler 1 CPK1. Obviously we've already done that. Let me see if I can do it. This glorious IDE won't let me do a copy and paste. Cycler 1 $CPK3 cycler $1 CPK4. Let me just make sure I don't have any typos. Okay, it looks okay. Okay, so now we've got a comparison, which is okay, but here again we're going to need to specify what these things mean. And so let's go ahead and do a y-axis CPK. And now we're going to use a vector for the names. So we're going to say time 1 time 2 time 3 time 4. Okay, so now we're labeling everything. Actually, for some reason, oh, I should have said names. That's why. Let's try this again. Names. Okay, there we go. All right. So that looks good. Now, what we're going to do is dress it up just a little bit, and we're going to dress it up with some colors. And here again, we're going to use a vector just like we did on the names. So we're going to say col equals vector, and we'll go ahead and get creative here. Not really. Make sure I don't have any typos. Okay, so that looks a lot nicer. Now it's easier to distinguish between them. Okay, so R has some really nice built-in things that we can do. So let's go ahead and convert what's known as a wide file into a long file. And the reason we're going to do this is so that we can probably do a better job of representing the data. So we're going to do this 4 times. So I'm going to create an object. So we're going to say cycler 1. And now we're going to subset this. Okay, so with a vector 1, 2, 3, 4, 5. So if you take a look at CPK1, basically you have the whole thing except for the other CPK columns. So we've just extracted it to the 1, and we're going to do this several more times. Now here, instead of 5, we don't want 5, we want 6. Right? It'll skip the 5th column. So if I say CPK2, notice it's got CPK2 up there. Now we're going to say CPK3. It says 6, we'll do 7. And finally, we're going to do CPK4. And the reason we're doing this is then this will allow us to combine these in more unique ways that will give us more choices as we render this. So we're going to go ahead and assign the name to each one of these. Names sub CPK1 sub 5 CPK. We're going to repeat this for each one. That way each one is going to have a name. All right. If you do names sub CPK4, it'll reflect what we did. Okay. That way, the names before were CPK1, CPK2, CPK3, CPK4. We want to have it so that they're all named the same thing. Okay, and now we can create a stack. Okay, so we're going to create a stack. We're going to say CPK stack signed rbind, row, that stands for row bind, and we learned that before. We just take a look at that. So notice that they're stacked now. Remember, we said we were going to convert this whole thing from a wide file into a long file. So that's essentially what we've done. Okay, so now let's do a box plot of that and see what that looks like. Okay, box plot, CPK stack, CPK, and remember, when we're doing something like this, it's a weirdism. It's Y versus X. And that's the treatment. Okay, so now we have actually probably a better and more meaningful thing. So now we have this is by treatments, right? So here's the high treatment, the low treatment, the medium treatment, and N stands for no treatment. So it just gives you a much better way to visualize. So let's go ahead and decorate this just a little bit and see if we can make it look a little nicer. X label equals treatment. Y label equals CPK. So main title equals CPK versus treatment. Let's do colors equals, we'll have a vector. We'll go red, pink, yellow, green. Let me just check real quick for any typos. Well, I believe I missed a comma here. Sorry about that. Put that back in here. Okay. Now we've got this. Let's colorize. We have our labels, and so it's a lot easier to see what we're trying to do. So what does this tell us? It compares the treatments and their effectiveness. Okay, so now let's kind of switch gears a little bit, and let's take a look at how gender played into this. CPK stack, CPK, tilde, CPK stack, gender. So we kind of roll gender place. So now we notice we only have two boxes because we only have two genders in this data. Okay, so let's go ahead and make this a little bit more palatable. X label equals treatment. Y label equals CPK. Okay, so now let's do something even more different. Let's go ahead and use the treatment and the gender together and see what we get here. So box plot, CPK stack, CPK tilde. And here we're going to multiply treatment times gender, so CPK stack. And notice that they're factors, so what's going to get multiplied, oops, what's going to get multiplied is the actual data behind it. And let's go ahead and make this more palatable. XLab equals treatment. Excuse me. YLab equals CPK. Main equals CPK versus treatment. Now let's give it a color vector. Let's see what we got here. Red, pink, yellow, green. All right, let's see what we get from this. Nice. Red is an incorrect color. Okay, so that fixes it. So now we've got actually quite a few data points, all comparing different things. So this is actually giving us a lot more visual information. Okay, so now we're gonna go to a different data set, and let's go and read it in. And here again, this should be part of your this should be in the R data. So let's take that rdata.zip file. Let's just take a look at this. Okay, so we have gender, shift, weight gain, and met min. So this is about weight gain and amongst different shift workers. Okay. All right, so let's do a histogram. D weight gain. Okay, looks pretty interesting. And notice you're going to have to describe that on your test as well. Okay, so let's go ahead and dress this up just a little bit. Okay, now we have labels on it, which is good. Let's go ahead and add a little bit of color here. Okay. Now you'll notice that things aren't necessarily lined up that well, so we have a way to make that line up a lot better if we do give it that command. It's not going to be required of you to do it, but okay. So that actually lines up a lot better. Okay, so that's enough of that. There's actually a really interesting way of doing colors. There are a number of built-in color ranges, and so you can actually use these built-in color ranges. Notice here I've got this heat.colors, and it's going to tell you how many how many gradations. It's like a gradient, and that just the number, that parameter, tells you how many different shades you want to go from start to finish. Okay, so here I'm going to go ahead. By the way, there's heat, there's rainbow, there's terrain, there's topo, and there's CM on those built-in color ranges. So here we've got this. Now we're going to go ahead and subset this. And so I have WG.M, WG.F, subsetted for the genders. Now we're going to go ahead and box plot that. Remember that for this it's going to be x comma y and not y comma x as those things we've been doing. When you use the tilde, it's y x. Okay, so that's interesting. We also want to go ahead and take that and put labels on it and names on each one. And let's check the levels that we have here. Okay, so that shows us the different levels we have. Now we're going to subset even more. We're going to go ahead and subset all of the different levels. Okay, so based on those levels, I'm going to go ahead and subset them all. Okay, so WG.7A, 8A, so forth. You don't have to do that, but just to kind of show you what's going on there. Now what we're going to do is plot all of those, and this next one is going to be kind of a monster. We're going to plot all of those together so we can do a comparison. Notice now on our graph here, they're all done. What we really should have done was put some sort of a coloring to them. It's pretty boring. So we can actually go through quite a few of these, quite a few permutations. Let me just change to plotting the weight gain against the metabolic number. Okay, that's good. That's pretty boring. Let's see if we can dress it up a little bit here. Okay. Now let's go ahead. Now what's interesting is you'll notice that these pictures are just little zeros, but R lets you actually go ahead and pick different like shapes. Now it's a little triangle. This thing over here, PCH2, I can change that to like a 3, like a 4. If you look online, there's a chart online that you can go and see what makes the most sense for what you're trying to do. So that's it for that graph, for that data. Now I'm going to load in some Dell computer data. And let's just take a look at that. Head D2. Okay, it's just, these are just stock prices between Dell and Intel. And what we're going to do is get a list of the numbers from the left side. So T1 is just going to be a vector of the numbers. Those are actually the names of. Now we're going to go ahead and plot that versus the Dell price. So our graph changed. And we can go ahead and say how we can make this a lot nicer, a lot more meaningful. And what we did, this type equals 1, that changed it to a line. Excuse me, type equals L means changes it to a line. So that's pretty interesting. And then we can actually add lines to it. Okay. For Intel, notice we have LTY equals 2, and that gives you the dots, the dotted line. Let's go ahead and add a legend here. Add a legend. That's actually pretty crappy, just because it's all kind of off the screen. But that's okay. So that's it for what I wanted to show you here. That's really all I had in mind to teach you before your test. So I would take this if I were you. By the way, there's a Word document on the web course that actually has this information all listed. So anyway, have fun, and I will open up your test sometime on Thursday. before it's time. I'll send out an announcement and let you know when that's going to be.